Okay, good everyone. Today I want to welcome everyone for today's special maths class, and I want to thank for all those who have been subscribing to our channels and making our videos go viral. Today we're going to be talking about a very interesting topic, sine rule. Now, last week we concluded the discussions on the use of Pythagoras theorem and then the trigonometric ratios in finding missing sides and missing angles. Today, we are going to focus our attention on non-right angle triangles. We're going to focus our attention on non-right angle triangles. Now, and that brings us to the introduction of the sine rule. Now, a non-right angle triangle is that kind of triangle that is not a right angle triangle. So, you talk about the acute angle triangle, you talk about the obtuse angle triangle, all those kinds of triangles, as long as they are not right angle triangles, they are all categorized under non-right angle triangles. And you are not expected to use Pythagoras theorem to find the missing sides of non-right angle triangles. You're not expected to use SOHCAHTOA to find the missing side or missing angles of non-right angle triangles. So whenever we are faced with a problem involving non-right angle triangles, we are expected to employ what we call the sine rule or the cosine rule. And we're going to see the cases in which we are allowed to use the sine rule and the cases we are also allowed to use the cosine rule. In the next video, we're going to consider the cosine rule, but for particular emphasis, we're going to talk about the sine rule today. Now, the sine rule is a special rule developed to find the missing side or angles of non-right angle triangles. The beautiful thing is that we can also use it to find missing sides or missing angles of right angle triangles, but we can't do it on the reverse. So the sine rule has two versions, and we're going to consider the two versions today. The sine rule has two versions. We'll go over here. The first one is called the side version, which we are going to focus on today, the side version, and the second one is called the angle version. Now, the side version is used to find missing sides. The side version is used to find missing sides, while the angle version is used to find missing angles. We're going to take everything step by step. Just follow us as we go through it. Now, the side version is quoted as thus. This is how the side version looks like. A over sine A is equal to B over sine B. I'm going to define what A is. A is always called the side you are looking for. Call the side we are looking for. So any side you are looking for, label it A, irrespective of what alphabet has been used to actually label that particular side. While this capital A is the angle facing the side you are looking for, the angle facing that side, which is A, the angle facing the side we are looking for. That's what that capital A stands for. We'll go over to the other side. Then small letter b is the side given, because a side will be given, and capital letter B is the angle facing the side given. the angle facing the side given. Now, from these two descriptions we have made about A and B, we can now take note of the condition for using the sine rule. Condition for using sine rule. Please pay attention to finding missing sides. To finding missing sides. What is the condition for using sine rule to find the missing sides? Now, the condition is simple for finding missing sides. Two angles must be given. There are two conditions that you must take note of before you use the sine rule to find missing sides. Two angles must be given. And secondly, one side facing any given angle must also be given. Must also be given. So these are the two cases in which, or two conditions in which we are allowed to use the sine rule to find missing sides. So I'm going to draw a triangle, and I will call here A, call here 40, call here 5, and call here 50. Now this is a case in which we are allowed to use sine rule to find a missing side. Now recall what I said. You must be given two angles, and you must be given a side, and that side that is given must be facing one of the angles given. The side you are looking for must also be facing its own angle that is given. So please take note of these conditions. You can now quote your formula to find this particular side. The formula says that A over sine A is equal to B over sine B. So we are going to have that your A here, you write it, that's what you're looking for. The angle facing your A is going to be sine 40, given the B is the other side, given all over its angle facing that side, which is sine 50. Whenever we have two single fractions on both sides of an equation, we are expected to cross multiply. Remember that the B was given to the 5, so we have to replace it with 5. So I'm going to have A sine 50 is equal to 5 sine 40. To find your A, you divide both sides by this sine 50, so I'm going to have A sine 50 over sine 50 is equal to 5 sine 40 over sine 50. This will cancel this, and your A is going to be 5 sine 40 over sine 50. For those who have a calculator, you can press that and you also get your answer. We'll take a second example to also elaborate more on what we have said now. Okay, so I have this type of triangle. Let's call here 60, and let's also call here 70. They give me here as A. Now you can guess which other side they are likely to give me. They must give me here, because this is the side that is going to face this angle. So let's assume that this is 6. You are expected to use sine rule to also find the missing side. So I'll leave you with this to also try and use it in finding missing side. Now, if you do a flip up of the side version, you're going to get the angle version. And we said that we use the angle version to find the missing angles. The angle version is just a flip up of the side version, which is sine A over A is equal to sine B all over B. If you also flip the opposite of the condition for the side version, you'll get the condition for finding the angle version. So the condition for the angle version says two sides must be given. Two sides must be given, and one angle facing any of the sides must also be given. Facing any of the sides must be given. Let's come over here. Must be given. Let's take an example immediately. We're going to have that two sides. We have 5 here, we have 6, and we're going to have 40 here. Let's assume that this is called our A. So we are going to call this the angle we are looking for A. We are going to have that sine A all over A is equal to sine B all over B. It will be very easy for us to find this now. Our sine A is going to be the angle we are looking for, which is given there. Sine A all over the side facing it, we have it as 5, is equal to sine B, the other angle that is given, which is sine 40, all over the side facing that angle, which is 6. If you cross multiply, when you have two single fractions, you're going to have that 6 sine A is equal to 5 sine 40. To release your sine A, we're going to divide both sides like I'm doing here by 6. And then finding this angle A, you're going to take the sine inverse of 5 sine 40 over 6. And for those who have their calculator, you can press it. So we've come to the end of today's class. We have taken note of two key things, using the sine rule to find missing sides and also using the sine rule to find missing angles. In two cases, one thing is ascertained. Number one, to find missing sides, you are going to be given two angles and a side facing any of the given angles. To find missing angles, you're going to be given two sides and one angle facing any of the given sides. It's just as simple as that. So try it out at home and you'll be able to get it. It's very interesting and I know you're going to enjoy the whole class. Thank you for being with us.